in a nutshell, can you kind of describe the jobs that you've pumped compared to what you would do now? Your learning curve has obviously come along.
Yeah, it's interesting. The learning curve, again, is to go from the fully cross-linked systems, if possible, trying to keep them, we're reducing polymers, trying to do everything I can to maximize conductivity, which may be through proppants, maybe through a CnF product. But what I'm trying to do is essentially have the cleanest hydraulic fractures possible and being able to produce at the lowest pressure possible and be able to maintain my reservoir pressure and not lose it due to damage through my proppant packs.
Do you think that this is going to alter this change of strategy? Does that impact job size? Does that impact any logistics issues? And then ultimately, obviously, what about well performance?
Yeah, all the above. It's hard to, all those could be touched. Can I make the same amount of production or get the same amount of production with a smaller job? Because I've got a cleaner fluid, I've got a fluid that's, cleaner fluid, cleaner proppant pack, or the CnF allowing me to produce at lower rates. You know, can I go ahead and can I go ahead and pump a smaller job and save money in that manner? Yeah, there's a chance that you could do that.
Did I hear you just raise an environmental issue, that there might be environmental consequences of a smaller job?
That's a good point. Yeah, I mean, again, the amount of water I'm using, reuse of the water, it's a problem we all are facing right now. In every basin that I've worked in, the use of water and where I'm going to get it is a big question. Even here in the DJ Basin, it's harder to get water if I work in the oil business. They will ask where we're going to use it. If I tell them for an oil company, I may not be able to get it. And also there is a separate price list. If I work for an oil company versus a farmer, I will pay 3 or 4 times what a farmer will pay for the same water.
So there are several drivers to having the smallest possible job, the best performance of the well. And if don't mean to put words in your mouth, but I sort of hear you saying that the use of CnF may be a player in that discussion.
Yeah, very much so. Again, if I can get the same amount of production with a smaller type job or less fluid, and the CnF is the driver for that, again, the cost benefit of what I get by using CnF is greatly outweighs its initial cost.
When you use it, a lot of operators tend just to put it in the dirty fluid stages of a treatment. Do you see any reason to broaden its use? To consider it in the pad or the flush, or perhaps even in the fluids in the well when you're perforating?
Yeah, very much so. I use it throughout the treatment. And the reason I do that is the first fluid on the rock is going to wet that rock. And so without having the CnF in it, we're not going to get the advantages of having that. In addition, it's not a piston type of effect, first in and goes automatically to the end. When I'm creating natural fractures and opening up natural fractures from the wellbore from the first gallon I put in, and what we've seen in many cases, just pumping our defits, that even pumping a couple thousand gallons of fluid, I know I'm getting out several hundred feet. I am touching a fracture face from the wellbore all the way out to several hundred feet. So I want that fluid to be able to be containing my CnF product. In addition, that CnF product also imbibes and continues to flow out into the matrix rock. And so again, I want that all the way through my initial pad treatment as well as through my proppant pack.
You raised the issue of volumes. Do you have any sense about any critical concentrations, gallons per thousand, that kind of idea for the use of the CnF?
It's something that we've really done, that we've used CESI, and now even Halliburton has it in its local facility here in Brighton. We've actually done testing with cuttings and with core to determine what the optimum concentrations would be, or in fact optimum and even critical concentrations, which I think is another key point. What I've seen is if you don't pump enough of the product or have a critical concentration, say you pump at a gallon or a half a gallon, and the critical concentration needed for the fluid to even work is 1.5 gallons to 2, you might as well not even pump it. At that point, you're just pumping a very expensive surfactant.
Just as a ballpark number, do you have any sense of how many wells you've used the CnF or its derivatives in?
Again, in the last 10 years, I'd say 90% of the wells I've been involved in, at least 80%. So I'm going to say thousands of wells now that I've been involved in using CnF.
So it's becoming a fairly compelling database.
Yeah, here in the Codell Niobrara play in the DJ Basin, and we also, in another basin we used it that was up in the anticline, up in for Jonah and the anticline area up there. Yeah, we have used it for years. And in fact, when I was with Halliburton, I had won an award for best new product for using it up in the anticline basin.
Do you think any other wells, I mean, there have been a lot of surfactant systems used that didn't necessarily contain a CnF. Is there any opportunity to be gained by doing restimulations that might use a CnF in it? Yeah,
very much so. The DJ Basin is one of those unique basins that refracts, and particularly in the vertical wellbores, have been extremely successful. We essentially doubled reserves by refracking and even tri-fracking wells in the DJ Basin. We are just starting to look at refracking the horizontal wells, and yeah, I definitely see a big place for the CnF product. And again, anytime I can look and see where a product allows me to produce at a lower pressure at the same rate, that's going to be a product that I want to use.
That's good news, isn't it?